Hello, welcome to the demonstration of our full prototype system. Here we're going to show how the input and the output system, which we described in the walkthrough, all work together. So I'll just position the lamp. As you can see, the power supply is on, so the H-bridge LED is activated. And now I just plug in the microcontroller and that activates the system. So our microcontroller has a built-in 10-second delay or 15-second delay, I believe, before it starts for our prototype demonstration purposes. And just for the first trial, we're going to show how it can find the light source in the room. So as you can see, the input scanner is scanning through the range of angles, displaying the millivolt voltage output on the LED display, and it found the output maximum power point angle. And as you can see, the output panel is tilting to match that angle. And if we go into profile here, we can see how the output panel has matched the input panel, and you can see how it tracked the light source in the room, which is just a ceiling sconce in this case. So our system should work for tracking a solar light source. And now to show how our system will change angles, we'll turn on the lamp, and it should start scanning again shortly. There it goes. So the angle will be different this time. As you can see, the input sensor found a new maximum power point angle, and our output panel, is activated. The linear actuator activated, and as you can see in profile, they match the angle, which is what we were trying to achieve here. Now we're going to move the lamp to simulate a new solar position. So I'm going to put it here. It's going to simulate around high noon, about 180 or 0 degrees flat. And it's important to note that in normal operation, the system wouldn't be moving between such great angles, because we would have a delay set in of about every 30 minutes, so that every 30 minutes or so, or 45 minutes or an hour, the system would sample, because you wouldn't want the system to be constantly activated. So as you can see, our input sensor system found the angle of the light source, and our output sensor system is being relayed the position from the microcontroller through the input system, and it's being moved to match that position. And for this example, as we can see in profile, the end position, so our output system has stopped moving. The end positions don't quite match up, so there is a little bit of error, which will be described in the software demo, in about 10 degrees in this case. So in the software demo, where we describe the microcontroller control code and the control method, it'll be explained why there is that little bit of error. And now for one last position, we'll just show how it can move back the other way. Although in normal operation that wouldn't typically be needed, because every day you would want to reset the system to match the sun rising in the east, and setting in the west. But just in this case, we're going to show how our system does automatically know which way to move. So as you can see, our input sensor system found the angle, and our output sensor system is being sent back the other way to match the maximum power point position determined by the input sensor. And if we look at it in profile, we can actually see that the error has appeared to disappear. So it seems that over time, if the system moves opposite directions, any error could be dampened out. And obviously every day the system would be reset by an automatic code which will be programmed in. So that's the end of our demo of our full system. All the individual subsystems were described in the walkthrough. Thank you for watching.